So our first device that we want to talk about are going to be our virtual switches. Now, our virtual switches are going to allow us to have the same functionality on a virtual environment as we would using a physical switch. Now, why do we need a virtual switch? Why don't we just connect our server to a physical switch and use it that way? Well, our virtual switch may allow our different virtual computers inside of our single physical computer to communicate with each other as if they were communicating through a switch, rather than having to go out to a physical switch and communicate back, or having to all be on the same subnet or all be on the same virtual LAN. Now, we can set up these virtual switches just so they have the same connectivity as if they were a physical switch. They can communicate with each other over layer 2, they can communicate within the same broadcast domain, and we can also use these virtual switches to set up VLANs. Now, our VLANs that we've talked about before, our virtual LANs, allow us to segment up our network. So if we're using a single, very heavy-duty physical server in order to set up multiple virtual servers within it, then we may need to set up a virtual LAN within that virtual server, or within that physical server for those virtual servers, because we don't necessarily want all of those virtualized devices to be on the same network. And this also allows us to utilize a single network interface card as a trunk port, rather than having to have multiple network interface cards with our multiple virtual LANs and then utilizing those network interface cards. So let's take a look at how this works together. So in our virtualized environment, we have our single physical server here. Now, our physical server has its own IP address, and it's on a particular subnet. It's on a particular virtual LAN. But we aren't really going to really think too much about this physical server right now. What we're focused on are these virtualized servers within our single physical server. These may be servers that provide data. These may have folders on them or shared folders on them, or they may be providing different services like DHCP, or they may be providing DNS. It really doesn't matter. But what we have in the middle here is going to be our virtual switch. Now, we have our different computers and our servers color-coded so we can get a better idea of how this is all working together. Now, we have our red devices here, our two servers and our physical client computer that are all on the 192.168.2.x. That's going to be our red devices. And then we have our blue devices here that are all on our 192.168.1.x network, or VLAN rather. Now, if we just had our single network interface card, it would be a little bit difficult for these devices to be separated out into different VLANs, because that single network interface card is going to send out those packets to a single port on our physical switch. So we need something inside of our server, our physical server. We need a virtualized component in order to identify which VLAN those packets are coming from. Now, we do have our different devices segmented into different subnets, so we would be able to use a single network interface card either way, but we're going to go ahead and identify those on VLANs as well in order to better segment our network. Now, we have our virtual switch here, which is going to connect to all of our different devices virtually via its standard access ports. So we would set this up and have our virtualized switch here. And then we would configure it to talk out over our network interface card using a trunk port. Now, we've talked about trunk ports earlier. Trunk ports, essentially what they do before they send out packets over that connection, they tag which VLAN that these particular packets are from. So before it sent a packet, say if our server here, 192.168.2.3, needed to communicate with our red client over here, 192.168.2.7, our switch, before it sent that packet out over the trunk port, would tag that packet and say, okay, this packet is on the red VLAN. So it would tag that packet, and then it would send it out over the trunk port. It allows communication between two different switches which manage VLANs over a single port, rather than having to have a different setup or not be able to communicate between these two switches. Now, we have our physical switch outside of our single physical server. This is our physical switch, and then we have our virtual switch. And our physical switch is actually going to receive that information over the cable that's plugged into it from the server, and then identify those packets and identify which VLAN that they're on. So we'll get the packet over our trunk port, and then it'll say, oh, okay, this is for the red VLAN, so I'm going to send this out on the red VLAN, and it's directed toward 192.168.2.7. And it'll send it on down. The same exact scenario in reverse if we have one of our clients, say 192.168.1.7, trying to communicate down and over to our servers over the trunk port. We'll also take those packets and they'll tag them, and then they'll go ahead and pass them on. So for example, if we have one of these servers, we'll say 192.168.1.3 performs DHCP. This particular port on this switch is identified as being the blue VLAN. So this port on the switch knows that it's already the blue VLAN because this computer won't have an IP address yet. So we can't segment our VLANs based on IP address because this computer doesn't have an IP address yet. So we have to segment our VLANs based on port. So this computer connects into our network, and we want it to be on the blue VLAN, so we plug it into our blue VLAN port. It sends out a DHCP request, which is a broadcast request, over our switch through our network interface card, over our trunk port, and to our virtual switch. Our virtual switch we have set up that our computer that is virtually connected here and our computer that is virtually connected here are both on the blue VLAN. So it'll go ahead and pass that DHCP discover message onto 192.168.1.3 and 192.168.1.4. 192.168.1.4 does not perform DHCP. 192.168.1.3 does. So then it'll communicate back with our non-IP address computer here. It'll offer it a DHCP, or it'll offer it give it a DHCP offer it an IP address. Our computer will accept it, and then it'll assign it 192.168.1.7. That's the function of our virtual switches. That's how our virtual switches compare to our physical switches, and how we can use our virtual switches to allow us to do things such as set up VLANs and use a single network interface card on our server as a trunk port.